now going to look at chapter 13, which is about rational and irrational numbers. A rational number is one that can be written as a fraction, so 2/3, 4/5. You also can get negative rational numbers, and that's absolutely fine, so -2/3 is fine. 6.5 can also be written as a fraction. It's the same as 6 5/10, or 65/10. 100 can be written as a fraction, 100/1. So those are rational numbers. We're going to have a look now at recurring decimals. There's a few stages to help you get the recurring decimals into fractions, and this is how you do it. Step 1 is write x equals the recurring decimal. Step 2 is work out 10x if one digit is recurring, 100x if two digits recurring, and 1000x if three digits are recurring. Step 3, subtract the 2. Step 4, rearrange to get x equals. Step 5, if you have a decimal on the top line, you move the decimal point on the top and the bottom, so you no longer have a decimal. And step 6, cancel your fraction if you can. It's actually a lot simpler than what that sounds. So have we look at this one here, 0.27 recurring. Step 1 is telling you to write x equals the recurring. So it's 27, 27, 27. Step 2 says that if you have two digits recurring, which I have here, you work out 100x. Now I'm just going to pop it on top. So 100x. So I'm going to multiply this by 100. So multiply by 100, move your decimal point twice. So it's 27.272727. You want your decimal points to be in the nice straight line there. Step 3 says you subtract the 2. So draw a line and subtract. 100x minus 1x is 99x. And if you subtract all these recurring bits, you should knock off 27, take away 0 is 27. Step 4 says rearrange to get x equals. So you're going to bring that 99 over and divide. Step 5 is checking for decimal points. There are no decimal points. Step 6 is cancel down. I can divide both of those by 9 to give me 3/11. Have another go at one of those. We'll try this one here. 1.056, and the 56 is recurring. So step 1 was let x equals 1.0565656. Write out your recurring decimal. You've got 2 recurring, so you multiply it by 100. So I like to put that on top, it makes it a wee bit easier. Multiplying this by 100, you get 105 point. So 105 point, make sure decimal points are in a straight line. And then, so it's 105.65, 65, 65, 65 recurring. And you subtract them. The recurring bits always knock off. 6 take away 0, 5 take away 1, and 10 take away nothing. 100 take away 1 is 99x. So this time you rearrange again, same as before. So x equals 104.6/99. In this question I've got a decimal on the top line. You don't want that. So you move your decimal point once, but you must move it down there. So it's 1046/990, because you fill the gap in with 0. And now you want to cancel down. So both of those numbers divide down by 2. 2 goes into that 523 times, and 2 goes into the other one 495 times. And that's you finished because it doesn't cancel down by anything else. And I'll have a go at another one with 3 recurring so you can see what that's like. So for example 3, I'll do 0.6702. Now, first stage, write x. So let x equals 0.6702. Just need to write out a couple of the recurring. Write out 2 or 3 times is fine. You've got 3 recurring this time, so you're going to multiply it by 1000x. So I've got to move this 1, 2, 3. So it's 670 goes on top, 670.2702, and you can just repeat your recur there a couple of times. Draw your line, subtract. These all cancel off. 2 take away 6 you can't do, so you've got to borrow. So you do normal subtraction there. 6, 9, 6, 6. 1,000 take away 1 is 999. Bring your 999 over to the other side. 669.6 divided by 999. You've got a decimal on the top. Move it once. You must balance out by moving it once there. 6696 over 999. You've left the gap, so you put a 0 in there. And you want to cancel these down. These all divide by 3. So 2232 over 3330. You can divide both of those by 2 to give you 1116. And dividing that by 2 gives you 1665. And that can cancel down again. I think that cancels down by 3 to give you 372, and 1665 divided by 3 is 555. I'm just going to check if that cancels down by 3 again. The bottom divides by 3 and the top divides by 3. So 124 over 185, and I don't think it goes any lower than that. I'm going to have a wee look at irrational numbers now. These are numbers which cannot be written as fractions, such as root 2, root 3, root 5, root 7, pi, which is 3.14, but it goes on forever, and 3 times pi. Basically, any number in your calculator that just gives you a big long answer in the display generally is an irrational number. Now, I'm going to check the following to see if they're rational or irrational. Now, I don't know what that is, so I'm going to do a bit of work with it. Change into improper. 6 times 4 is 24, add 1, 25 over 4. The square root of 25 is 5, square root of 4 is 2. So that is rational. This one here is a third, that's rational, but root 3 is irrational. So that complete answer there would be irrational. Part C, 1.5, I'll write that as 3 over 2, square it, 9 over 4 is a fraction, rational. The square root of 6 does not break down, so that whole expression is irrational. Part E, I want to write that a little bit differently. That's pi over 1 times 2 over pi. Those pi's cancel down to give you 2 over 1, which is just 2, a rational number. Root 3 squared, that is root 3 times root 3, which is root 9, which is an ordinary 3, which is rational. Because remember, an ordinary number can become a fraction by putting it over 1, so that would be rational. Part G. 0.2 is the same as 2 over 10, or a fifth cubed. 1 cubed, 5 cubed is written as a fraction. It's rational. I could have went through that and wrote 0.2 times 0.2 times 0.2 to give you 0.008, and then write 8 over 1,000. That's absolutely fine. It will get you the same answer. H. To check this one out, I'm going to fix it up a wee bit. So I'm going to move a decimal point, so it's 25 over 2. That's written as a fraction as it is, so it's rational. I needs a little work to it. So 4 times 4 is 16, add 1, 17 over 4. Square root of 17 doesn't work out evenly for you, so that's an irrational number. J. I'll be doing more work with negative indices later on. What a negative index means, it means 1 over the positive index. So I write that as 1 over 3 to the power of 1. I write this one as 1 over 3 squared. So it's a third plus a ninth. A third, make the bottoms the same, so it's 3 over 3 plus 1 over 9, which is 4 over 9, which is rational. And the last one is pi, is an irrational number, plus 2, so the whole answer is irrational.